Hello friends, the question is like this: write the minors and the cofactors of the elements of the following determinants. In this question we have been given these two parts, and in these two parts we have been given two determinants and we have to calculate or write the minors and cofactors of each element in the given determinants. Okay, now the first part we have been given this determinant 1 0 0 0 1 0 0 0 1. Okay, now m11, that is minor of the element a11, would be equal to the determinant obtained by removing the first row and first column, and would be equal to the determinant 1 0 0 1. 1 into 1 is 1, 0 into 0 is 0, so 1 minus 0 is equal to 1. Okay, likewise m12, minor of the element a12, would be equal to 0 0 0 1. Okay, and this will be equal to 0. m13, minor of the element a13, would be equal to the determinant 0 1 0 0, or simply equal to 0. m21, minor of this element, would be equal to the determinant 0 0 0 1 or 0. m22, minor of the element a22, and this will be equal to the determinant 1 0 0 1 or 1 minus 0 or 1. m23, minor of this element, would be equal to the determinant 1 0 0 0. 1 into 0 is 0, 0 into 0 is, we are going to get this as equal to 0. m31, minor of this element, would be equal to the determinant 0 0 1 0, again equal to 0. m32, minor of this element, would be equal to the determinant 1 0 0 0 or 0. m33, minor of this element, would be equal to the determinant 1 0 0 1, 1 minus 0 or 1. Now we have to calculate the cofactor. So cofactor of the element located at first row first column, that is 1, is represented by a11, and similarly the other cofactors. So a11 is equal to minus 1 to the power of 1 plus 1 times m11 or 1. Okay, because this will be plus 1 and m11 is 1. Okay, a12, it would be equal to 0 because m12 is equal to 0. The a13 would be equal to 0 because m13 is equal to 0. a21 would be equal to 0 because m21 is equal to 0. a22 is equal to minus 1 to the power of 2 plus 2, so this will be equal to 1, and m22 is 1, so 1. a23 would be equal to 0 because m23 is equal to 0. a31 again 0, m31 is equal to 0. a32 is equal to 0 because m32 is equal to 0, and a33 would be equal to minus 1 to the power of 3 plus 3, and this will give us 1, and 1 into 1 is equal to 1. Okay, so this is how we are going to calculate the minors and cofactor for the first part, and this is our required answer. Okay, now for the second part, the minor of the element, this element 1, that is a11, would be equal to 5 minus 1 1 2, or 5 to the 10, 10 minus minus 1 plus 1, 10 plus 1 11. m12, minor of this element, would be equal to 3 minus 1 0 2, 6 minus 0 or 6. m13, minor of this element, would be equal to the determinant 3 5 0 1 or 3 minus 0 or 3. m21, minor of this element, would be equal to 0 4 1 2, and this would be equal to 0 minus 4 or minus 4. m22, the minor of this element, would be equal to 1 4 0 2, this will be equal to 2 minus 0, 0 into 4 is 0, so 2 minus 0 or 2. m23, minor of this element, would be equal to 1 0 0 1, and this will be equal to 1 minus 0 or 1. m31, minor of this element, would be equal to 0 4 5 minus 1, that will be equal to 0 minus 20 or minus 20. M32 minor of this element 1, and this will be equal to 1, 4, 3 minus 1, and this will be equal to 1 minus 12 minus 13. Minor of this element M33 would be equal to the value of this determinant 1, 0, 3, 5, and this will be equal to 5 minus 0 or simply 5. Now taking the cofactor, A11 would be equal to 11, same as its minor, because minus 1 to the power of 1 plus 1 would be equal to minus 1 to the power of 2. Minus 1 is raised to the power of even number, so its value will remain 1. Okay, so the M11 would be equal to 11. Here I would like to discuss a very logical point, a very simple point, and it is like this, that we can calculate the cofactor A11 as equal to minus 1 to the power of 1 plus 1 times its minor, and likewise any cofactor can be calculated. Okay, but if we want to make a calculation very easy or fast, so what we can do, we can look here that these three elements 1, 5, 2 form a leading diagonal, and 4, 5, 0, these three elements form another leading diagonal. Okay, the cofactors are equal to minors for the elements in these leading diagonals. Okay, and for these remaining elements they are going to have the values multiplied, that is minors are going to have the value multiplied with minus 1 to give the cofactor. Okay, so the cofactor of this element 0, which is not in the leading diagonal, will be equal to the negative of the minor, therefore it is going to have the value minus 6. 4 lies in the leading diagonal, so minor and cofactor would be equal to each other, so A13 would be equal to 3. Okay, A21 would be is not located in the leading diagonal, so its value would be the negative of the minor, so minor here is minus 4, so A21 is equal to 4. A22, that is this element 5, is located in the leading diagonal, so its value equal to 2. A23, it is not located in the leading diagonal, so its value would be negative of its minor, that is minus 1. A31, located in the leading diagonal, so value same as its minor, minus 20. A32, it is not located in the leading diagonal, so its value would be negative of its minor, and A33, its value would be same as its minor because it is located in the leading diagonal. So we can calculate the cofactors with the help of the minors by just checking whether the particular element for which the cofactors are calculated is located in the leading diagonal or not. And what you have to do, you have to just multiply it by minus 1 if the element is not located in the leading diagonal to calculate the cofactor. So this is how we are going to calculate the cofactors and the minors for the second part, and this will be the required answer. Friends, thanks for watching my video. To watch more of these super videos and for the latest updates, subscribe and like the videos on these channels on YouTube, HSK Shiksha and Math Help by HSK. Thank you.